Sorry, I'm home with a sick kid, so we're going to do some quick notes, and I'm going to show you how to draw some waves, which you're going to be doing on today's worksheet. To wrap up how we describe waves, sorry, skipped a slide. Um, Wave speed, which we mentioned yesterday. Um, Wave speed is just basically meters per second, like we're used to. For any given wave speed, wavelength, and frequency are all related. A longer wavelength is going to give you a higher frequency, and speed is tied into that as well, because speed involves length. So if you have a wavelength of 1 meter, you're and it's passing, for example, the pole in this picture, once a second, you would have a speed of 1 meter per second. We also can describe a wave using amplitude. This is the distance from the midpoint, which we also referred to as the rest position before. To either the crest or trough of the wave. So it can be measured above, it can also be measured below. So this is basically the max distance from that rest space or from equilibrium. Amplitude can be spoken of in decibels. We also, on the worksheets you're going to be looking at today, it is also appropriate to use meters because of the scale that you're going to have on there. So I'll kind of show you that when we're working some of those problems out. You've heard the term decibel before in reference to volume. If you want to make a sound louder, you do so by increasing the amplitude of that wave. So basically the height of the wave will predict how loud it's going to be. We can contrast this with what we talked about yesterday, which was frequency. Frequency is what actually is going to change the pitch of your wave. So if you want a sound that is louder, you have to have a higher amplitude, and you've heard the word before, amplifier. An amplifier will increase your amplitude and thus make your sound louder. Whereas if we want to talk about making something a higher pitch, we have to increase its frequency. That's going to be related to wavelength. So you can actually change the volume of a wave, change its amplitude, without changing wavelength. However, in order to change pitch, you do need to change wavelength. You decrease your wavelength, you increase your frequency, which will give you a higher pitch. Some interesting things to think about in music. A chord is several notes of music that are played at the same time, and they're all different pitch, so they have different frequencies. You hear them simultaneously because velocity equals frequency times wavelength. So what actually happens when you play these notes is if wavelength is increased and frequency decreases, the product of those still remains the same. Your speed of sound in air is 334 meters per second. So if in this velocity formula up here, if frequency is going up for a high-pitched noise, your wavelength is going down, and vice versa. So when you multiply those two together, you get the same product of 334 meters per second. And the evidence of this is the fact that if you were to play a chord on a piano or a guitar, you would hear all of those notes at the same time. You wouldn't hear a higher pitched note first or anything like that. Radio waves are being transmitted through the air constantly, and these are transmitted at different frequencies that are picked up by your radio dial. So although you may not listen to the radio much these days, hopefully you occasionally do in the car, when you look at your radio dial and you see something like, for example, Hot 107.9, the oscillation frequency at which they're sending out that broadcast is in 107.9 millihertz. We do still depend on radio waves all the time, although not specifically necessarily in this range of frequencies, but this is also how technologies such as phones and things like that work as well. So one of the things you're going to need to do today is be able to draw a wave. You're going to be given a grid. On my grid, I did put this darkened line right here that you can see. So you do have that in your notes, but you're not going to have that on today's worksheet. What is going to be important is making sure that we utilize the scale that we are given. So we want to draw a wave with an amplitude of 6 meters and a wavelength of 10 meters. Typically, it's easiest to draw these as sine waves, and you need to make sure you have one complete cycle. Some people ask, can you go down first and then up? Yep, you can start totally in the middle of a wave if you want to, but I find it easier to start, with one of those two ways. If you start kind of in the middle, you have to be very careful that you really do a full cycle of the wave. So our amplitude is 6 meters, which means this has to go up to a height of 6 meters, and we have a wavelength of 10 meters, which means the full cycle of the wave must occupy 10 meters. Each block is going to equal 1 meter. Blocks also have a time designation on here that will allow us to determine period. So we're going to start our wave right here. Now we need this wave to go a total of 10 meters. So 10 meters is equal to 10 blocks. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 will show where one complete cycle of this wave will end. I'm going to choose to just start at rest position and go up first. I can also figure out that this will hit the rest position again at 5. That's half a wavelength. 1, 2, 3, 4, 5. So if I make this go up first, I need to go up 6 blocks. So I need to go up a height of 1, 2, 3, 4, 5, 6. I need to go up to right here. Now, it's best to try to draw these as symmetrically and, nice looking as possible. It's probably not quite as nitpicky as what you might do in math. So if we look at where my two little red lines are here at position 0 and position 5, right about halfway in the middle would be right about here, and I need to go up 6. So I'm just going to make a little point there. It doesn't really matter if you make a point per se, but it just helps me with my drawing. On the other side, I need to go down 1, 2, 3, 4, 5, 6. So when I draw my wave, I just need to make sure to hit those points like that. And this is one cycle of that wave. My wavelength will be measured from here to here. That's 10 meters. What I'm writing in blue, you do not need to draw on your drawing. It's depicted by your picture. And my amplitude of 6 meters or 6 decibels is shown right here. And again, you don't need to show that. I'm just kind of reiterating that. You also need to be able to determine frequency and period for a wave. From this particular drawing, it is much easier to do period first. Remember, period, or T is period, and that is in seconds. So we can actually look at this picture, go back to our key up here, and each block is 0.5 seconds, which means, I'm going to move everything in blue out of the way for a moment. If I want to count how many seconds a cycle of this wave took, this would be 1 second, 2 second, 3 second, 4 second, 5 seconds. So each of those green lines is indicating a second because each square is half a second. So 5 seconds went by during the course of this one wave. Therefore, period equals 5 seconds. Now frequency, I'm going to use my equation right over here. Frequency is the reciprocal of this. Oops. So frequency is going to be 1 over time. Excuse me for a moment. Frequency in this case will be 1 over 5 seconds. And it's not really appropriate to leave this as a fraction. We are going to divide this out. 1 divided by 5 is 0.2, and our unit for frequency is hertz. You can also show hertz if you want to as seconds to the negative 1. Not necessary, and most people choose not to do that. So we're going to draw another wave. We're using the same scale we did in the last one. and you have an amplitude of 8 meters and a wavelength of 14 meters. So again, you're going to find that rest position. You will need to draw this onto the worksheet. You can use either the edge of a book or a ruler to do this. I'm going to count out my wavelength first. My wavelength is 14. So this is position 0, 1, 2, 3, 4, 5, 6, 7. Halfway. 1, 2, 3, 4, 5, 6, 7. Or 14, I should say. So that gives me my wavelength. I need to go up to an amplitude or height of 8 meters. So 1, 2, 3, 4, 5, 6, 7, 8. I'm going up to here. And I want to hit right about in the middle of these 2 points, which is going to be right about there. And I've got to go down 1, 2, 3, 4, 5, 6. Oops, I forgot what I was counting to. Sorry. 1, 2, 3, 4, 5, 6, 7, 8 down here. And again, we're just going to go ahead and connect our wave as such. Again, I'm not a perfect drawer, so you see that little blip in there. That's okay. Just make sure you're going down to the right height and you're balancing this out and making it look as nice as you can. So again, I'm going to do period first. So period is my number of seconds it takes for this wave to go by. Every block is 0.5 again. So this is 1, 2, 3, 4, 5, 6, 7. So this took 7 seconds. And you absolutely do need that unit of seconds with that. I'm going to make sure I put it on the last one. Yes, I did. Good. So you do need your unit of seconds with that. And then my frequency is going to be 1 over period, or 1 over 7 seconds. So the frequency of this wave is 0.14 hertz. Now, we should notice as we compare these two waves, so if we look at this wave, we have a shorter wavelength. So during a period of time, this would happen more frequently. So my frequency of this wave is 0.2. Our next wave with a longer wavelength would happen less frequently during the same period of time. Because it's happening less frequently, we ended up with a lower frequency. So you can see that relationship between frequency and period. Quick rundown on what you need to be doing in your worksheet today. You're going to start by first reading this given wave. So from this wave, you need to be able to determine amplitude. Remember that little lambda means wavelength, frequency, and period. So the only 2 equations you're going to need, or the only 1 equation you're going to need, is the F equals 1 over T. Don't forget units on every single one of these, please. Again, it's acceptable for amplitude. You can use either decibels or meters. Wavelength is a length, so that's in meters. Frequency should be in hertz, and period should be in seconds. So please make sure you have all of those units. On the back of this sheet, you're going to draw the given wave. You are, again, using the same scale on these. So we may come across some waves where we use a slightly different scale, but on this particular sheet, you're just going to continue to use the same scale. I do not have the kind of thicker line in here for you, so you should find a place to put that rest position, like right about here, to kind of make your drawing a little bit easier. Make sure you hand this into the sub before you leave, and I'll see you tomorrow.